So hello students, we'll continue again with unit number 1 and the last topic number 4, the ancient marvels in civil engineering and the future vision of civil engineering. The ancient marvels in the field of civil engineering. The first one is the Great Wall of China. The official number when it comes to its length is set as 5,500 miles. Its original length is estimated at a whopping 13,170 miles. So it has been found that the Great Wall of China was not just built under one dynasty, but at least 4 different dynasties during the 7th and 8th century before Christ. This is to be expected as its construction lasted for at least 2,500 years. The wall was commissioned by the Emperor Qin Shi Huang, who wanted to protect China from outside forces. This is a picture of the Great Wall of China. I know the pictures are not going to be clear and it is distorted, but if you want to get a more proper view, you can go through Google Images for the same. Next, the St. Basil Cathedral, Russia. Built in 16th century Moscow, the St. Basil Cathedral is one among the most recognizable man-made buildings of the world. It is also among the list of World Heritage Sites by the UNESCO. The cathedral was built by Ivan the Terrible, who had sanctioned it in the year 1554. The purpose of the cathedral was to showcase the military prowess that Ivan had over Russia during his reign. The legend surrounding the cathedral and even states that Ivan had purposefully blinded the architect so that he may not replicate the intricate design of the cathedral for any other of his works. The official name of the church is the Church of the Intercession. However, it got the name the St. Basil Cathedral after the death of Basil, a commoner who is known for his prophetic powers who was buried in the cathedral. The cathedral has 9 chapels and is undoubtedly the best site in the Red Square. The picture of St. Basil Cathedral at Russia. Number 3, the Taj Mahal, India. Taj Mahal is one among the 7 man-made wonders of the world and is something of sheer beauty made in lustrous white marble. The structure was built between the years 1631 and 1648 and was ordered as a memorial by the Mughal Emperor Shah Jahan to his late wife Mumtaz. The Taj Mahal closely follows Islamic architecture melded with Persian and Indian design language. It is situated in Agra, India. The structure required a labor force of 22,000 workers consisting of common workers and stone cutters. With such a large workforce, Taj Mahal took 17 years to finish. Taj Mahal also had many precious stones embedded in its structure. However, it is believed that most of them were pried out and stolen by the British during the rebellion. Picture of Taj Mahal, India. Number 4, Horyoji Temple, Japan. The world's oldest wooden temple, the Horyoji Temple, situated in the Japanese city of Nara. The temple was first constructed in 600 after death. However, due to a fire breakout, some parts of it were destroyed. The damaged parts of the temple were reconstructed during the time of 700 to 800 AD. The Horyoji Temple is a Buddhist temple that perfectly encapsulates Japanese architecture. The main attraction of Horyoji Temple is undoubtedly the 5-storied wooden pagoda, which is the most ancient wooden part of all the temple structures in the area. The central pillar of the pagoda extends 3 meters below the ground, giving it central support that is strong and uncompromising. Here is a picture of the Horyoji Temple at Japan. Next, Chanbari, India. Chanbari, the city of brightness, is situated in India and is intricate in any angle when we look at it. The Chanbari was built in the 10th century as a step well. Today, it is still one of the world's deepest step wells. It makes sense that the Chanbari spans so much into the earth's surface that it is constructed on the edge of the Thar Desert, one among the hottest places in India. The structure has about 3,500 steps that are put together in a zigzag fashion, creating a unique symmetry that is guaranteed to make you in awe of the workmanship of an age where they had no sophisticated tools to ease the work. Architecture of Chanbari, India. Last one, number 6, Mohenjo-Daro, Pakistan. Mohenjo-Daro is situated on the Indus Valley of Pakistan. The precise date of origin of the Mohenjo-Daro civilization is yet to be confirmed. However, there is a vague timeline that stretches its age as being 5,000 to 8,000 years old, positioning it as one of the oldest civilizations in the world. Mohenjo-Daro carried 40,000 occupants and was built on an idea of city planning. The complex yet carefully laid out sewer and drainage paths means that the Indus Valley occupants paid tremendous attention to the city's design. The next topic is future vision of civil engineering. Civil engineers will be entrusted by society to achieve a sustainable world and raise the global quality of life. Civil engineers as a body of professionals will be master of the following 5 plans. Number 1, planners, designers and constructors. Number 2, stewards of the natural environment. Number 3, innovators and integrators of technology. Number 4, managers of risk. And number 5, leaders in shaping public policy, where master implies leader in both role and knowledge. The first one, master builders. In order to achieve the first vision outcome, civil engineers as leaders in planning, designing and constructing the built environment will have to light the torch and position themselves at the helm of multidisciplinary global collaborative teams that carry out successful projects. In their role as master builders, they will have to acquire a new, more expansive body of knowledge, provide ethical guidance, attract a diverse workforce, and define the knowledge and responsibilities for each member of a well-defined hierarchy of professionals and paraprofessionals. In addition, civil engineers must educate their colleagues, partners, and the public on what civil engineers bring to the table and become knowledgeable vocal advocates of sustainable economic growth through infrastructure renewal. Number 2, stewards of the environment. Civil engineers will enter 2025 having long recognized the imperative for sustainable practices and the urgency for social equity in the consumption of resources. In that year, policies and the government fundings will encourage or require sustainability and resilient approaches. Civil engineers will have put new technology, techniques, and financial methods in place for sustainable planning, design, construction, operation, and maintenance and carrying out the vital role. In addition, civil engineers will routinely encourage owners to adopt new environmental technologies and techniques to improve the quality of life, while environmental stewardship becomes an integral part of engineering education and research. Number 3, innovators. To become master innovators and integrators of technology, civil engineers must define the strategic research direction for leading-edge technologies in the built and natural environment and serve as active participants and partners in the research process. This will take a variety of efforts, including identifying and prioritizing emerging technologies and innovations, fostering civil engineering input into strategic research planning, influencing and bolstering funds for research, promoting faster application of new technologies and multinational knowledge exchange, championing diversity and inclusion in the profession, and accelerating the integration of technology through spirited partnerships among diverse sections. Number 4, managers of risk. To achieve the managers of risk outcome, civil engineers will have to show their mettle in assessing and managing risk, forging new tactics for reducing the incidents and effects of natural and man-made disasters. Civil engineers will lead enterprise-wide risk management efforts and routinely make project-specific risk decisions, communicating risk and mitigation objectives to project colleagues, clients, government agencies, and the general public. At the same time, they will advance new approaches to a balanced business risk and reward. To have an impact, risk management must become a part of every civil engineering project, a step as basic as scheduling and budgeting and a key ingredient of all communication channels. The last one, leaders in public policy. Finally, to greatly expand their role as public policy leaders, civil engineers will possess the skill for broad-based policy discussions and serve as opportunity finders as well as problem solvers. Will become the go-to professionals for insights on public policy decisions that shape the built and natural environment. Through the efforts of civil engineers, policymakers and the public will understand the hardwired link between infrastructure and the quality of life. That means civil engineers must be given the tools and training for engagement in public policy work, while they become more vocal participants in public policy forums and increasingly serve in appointed and elected positions. Civil engineers will learn to lead and become motivated to initiate, communicate, negotiate, and participate in cross-professional efforts to envision societal changes that shape the quality of life. So that's all for this lecture. Write your name, enrollment ID, and section in the chat box. for attendance. We'll go through a few videos. Thank you.
सब्सक्राइब करें खबरें Civil engineering tends to be massive in scale by its very nature, but some civil engineering projects are so impressive that they stretch the imagination of what is possible. We bring to you the top 10 incredible modern marvels of civil engineering. At number 10 is Hoover Dam in Nevada in United States. Built during the Great Depression from 1933 to 1936, the Hoover Dam sits on the Colorado River. It is the largest ever dam construction when it was built. The arc gravity dam used several techniques in dam construction that were at the time untested. The result is a modern marvel of civil engineering that impounds the largest reservoir of water by volume in the United States. Launched by NASA on July 23, 1999, the Chandra Observatory is the world's most powerful X ray telescope. It is a satellite that allows scientists to obtain X ray images from high energy regions of the universe. These include events such as black holes, neutron stars, dark matter, and supernovas. The Chandra was named after India's Subramaniam Chandrasekhar, a physicist and Nobel Prize winner who discovered the maximum mass for white dwarfs. The Chandra is a third of the four great observatories launched by NASA. The Channel Tunnel, also known as the Channel, is a 32-mile underwater rail tunnel that links England and France beneath the English Channel. It is the world's longest stretch of underwater tunnel that began in 1988 and was completed in 1994. Recognized as one of the seven wonders of the modern world by the American Society of Civil Engineers, the tunnel's lowest point is 250 feet deep, while the portion of rail underwater is 23.5 miles. Train speed reaches 100 miles per hour, while a trip between the two cities takes only 20 minutes. The tunnel plays a crucial role in connecting the two countries and serves the transportation needs of over 7 million people a year who travel on Eurostar trains. At number 7 is the Three Gorges Dam, located on the Yangtze River and one of China's largest construction projects since the Great Wall. It is 1.5 miles wide and over 600 feet wide and almost 400 miles long. This innovative engineering feat creates electricity equal to 18 nuclear power plants. Construction of the dam began in 1994. It opened for commercial operation in 2008. It is the world's largest hydroelectric power station and the world's largest concrete structure. It, however, is plagued with controversy. The dam has created ecological problems such as landslides and pollution and has displaced over 1 million people and flooded archaeological sites. Have you ever wondered how the World Wide Web came about or how cancer treatments were developed?